Hello girls, this is lesson 10.5 solving trigonometric functions homework. I will be solving it so you can stop at the questions that you're suffering with or you're not able to solve and check how did I solve them. I hope it will help you. Okay, so I will start with question number 1. It says sine 2 theta equals to cosine theta. And here in this pack, they've given me intervals. They said from 90 to 180, and 90 is inclusive, 180 is not inclusive. So if one answer is 180, I would never use it, okay? So what shall I do? I would definitely think of double angle identity for this one. This one I cannot do anything, but here I can change this to 2 sine theta cosine theta. And then I think I should take this to the left, so minus cosine theta equals 0. Again, if the question said solve, you will need to find theta. You cannot stop before finding theta. And to find theta, you need to refer to the unit circle. I think taking cosine theta as a common factor is the right step over here. Minus 1 equals to 0. So 0 product property tells me that maybe cosine theta is equal to 0 or 2 sine theta minus 1 is equal to 0. When is cosine theta equal to 0 on the unit circle? Cosine theta is equal to 0 only here and there, okay? Only. The interval given is from 90 to 180, and 90 is included, okay, until 180. So I will not take the 180 because it's not included, it's opened at the 180. I will only take the 90 degrees or pi over 2. Since the question is given in degrees, I would solve in degrees. So here theta is equal to 90 degrees only, and I will not take the 180 because it's not in my interval, because over here they wrote it open. For this one, the question now is when is sine theta equal to half in this quadrant, or in this is which quadrants? These are quadrant 2 and quadrant 3. Sine is positive only in quadrant 2. Okay, so which number will have? I think it's 150 degrees. Cosine, sine, when is the sine? Over here, half. So you just write the answer as theta is equal to 150 degrees, and whenever you're not sure of your answer, you can substitute it and check. You can substitute it in the equation and check if you're right or wrong. Okay, for the second question, this is cosine theta. I cannot do anything to it, but this is sine 2 theta. And here the interval is 0 to 360, which means quadrants 1 and 2 and 3 and 4, all the unit circle, and only the unit circle. So for this one, I would change it to 2 sine theta cosine theta, and in the same step, I will send this here, so it will be minus root 2 cosine theta equals to 0. I think I should take cosine theta as a common factor, so 2 sine theta minus root 2 equals to 0. Now I can use 0 product property. Either cosine theta is equal to 0, we just said this happens only at 90 and 270 degrees. Okay, over here I'm sorry, it wasn't 180 anyways, it was 270, and 270 is not in the range anyways. Over here 90 and 270. And for this one, sine theta is equal to root of 2 over 2. This is a quarter, right? And only quarter 1 and quarter 2 sine is positive. So here only theta is equal to 45 degrees or 135 degrees. And these are 2 answers, and these are 2 answers. You do not need to add 2 and pi because an interval is given in this question. This question, I sent the answer. I will explain it again. It's a little bit different from the ones in the book, but anyways, we can handle it, or as a start, I don't know for theta, but I can handle cosine 2 theta is equal, minus cosine 2 theta is equal to 0. Okay, now what shall I do? This is exactly as cosine 2 theta. Okay, and take this as a pack معك. يعني هنا كأنها cosine 2 theta, but your theta this time is 2 theta. So cosine 2 theta, I can use 2 cosine squared theta minus 1. مظبوط. So 2 cosine squared something minus 1. My something here is 2 theta minus 1. Okay. This as is minus cosine 2 theta is equal to 0. So now I can rearrange to 2 cosine squared 2 theta minus cosine 2 theta minus 1 equals to 0. Now I have this equation is written exactly like 2x squared minus x minus 1 equals to 0. It's exactly the same, but I have cosine squared 2 theta instead of x, or I have cosine 2 theta instead of x. وهنا cosine 2 theta instead of x. So I can start opening two brackets. Thinking wisely, I would split this one of them to 2 cosine 2 theta and one of them to cosine 2 theta. If I multiply them, I will get 2 cosine squared. As I said, this squared means it's for all the cosine. So I can split this to 2 cosine 2 theta and this one to cosine 2 theta. This one has no option except 1 and 1. Maybe one is negative and one is positive to get a negative. And I want the bigger one to be negative, so I put the negative one over here and a positive one over there. So I ended in 2 cosine 2 theta equals to negative 1, and here cosine 2 theta equals to 1. Again, zero product property. So this says cosine 2 theta is equal to negative half. When is cosine in general equal to negative half? Cosine is negative in here and there, and cosine is negative at 120 and at 240, negative half. So, but this time I still have, I'm carrying with me 2 theta, so maybe 2 theta is equal to, as we just said, 120 or 240 degrees. So theta should equal to what? 60 if I divide by 2, or 120 degrees. Okay, there's no interval given in this question, so I should add. And the problem, another problem over here, if you're thinking of adding 2 and pi, this function cosine 2 theta, its period is not 2 and pi. It does not repeat itself every 2 and pi. I need to find its period because there is a b over here that's not 1. How will I find its period? Its period was, the rule for the period was 360 over b. And this was the b, if you remember. So the period of this function, it repeats itself every 180 degrees and not 360. So if I want to add to those, I should say 60 plus 180 and 120 plus 180. Okay, actually I have an interval over here for 180 included until 360. So let me see the answers of these. This one would give me 240 degrees and this one would give me 300 degrees. So now I have a possible answer which is 60, 120, 240, 300. Now I will not take 60 and I will not take 120 because of the interval. The interval are quadrants 3 and quadrants 4 only. So these are okay with me and these are not okay. I repeat in this piece again. So when is cosine equal to 1? Cosine is equal to 1, add 0. So 2 theta is equal to 0. So theta is equal to 0. I need to add the period to this. Okay, and 0 is not in my range. So I need to add the period, and we said the period is only 180 degrees. Okay, so plus 180, 180 is included. So plus 180, and that's it. So one answer over here is 180 degrees. That's also a possible answer. Why didn't I add another 180? Because over here it's opened and 360 cannot be included in your answer. Okay, a little bit complicated. The others are all very common, very obvious, I think. Question number 4. Now there is a cofunction identity in the first lesson that we took when cosine theta pi over 2 minus theta is equal to sine theta. Okay, so cosine theta plus sine theta is equal to 0. In other words, cosine theta is equal to negative sine theta when on the unit circle, and they want one round and they want the answer in radians. When does this happen? Means when are they opposite signs? They're opposite signs and equal only in 2 places. Over here they're opposite signs and equal, and here they're opposite signs and equal. So over here this will satisfy me if I use, for example, cosine theta, which is negative root of 2 over 2, and here sine theta is root of 2 over 2, and with this negative the equation is satisfied. And for this one, cosine is root of 2 over 2, so if I wrote root of 2 over 2 equals, and over here is negative root of 2 over 2, negative root of 2 over 2, and I have another negative over here, so root of 2 over 2 equals root of 2 over 2, and it's also satisfied. So the two quarters with opposite signs are 135 and 315. They want the answer in radians, 3 pi over 4 and 7 pi over 4. And this is the answer, 3 pi over 4 or 7 pi over 4, and these are the only possible answers here. Okay, the next question, I would go to Pythagorean identity to help me make this all cosines, because I don't want sine and cosine, and I want to factor, and this is not very helpful. Sorry, my camera. Okay, I will fix it. Okay, not yet. Okay, a little bit better. Type. Over here I can change this to 2, 1 minus cosine squared theta, and this is 2 plus cosine theta. Rearrange, I will distribute and take to the left side. This 2 will come to the left side as a negative 2, so here I have those and a minus 2, and this is minus 2 cosine squared theta will be plus 2 cosine squared theta equals to 0. These will cancel each other. I can take cosine theta as a common factor. This is 2 cosine theta plus 1 equals to 0. The interval over here is from a quadrant after 180, only quadrant 3. From 180 to 270 only, okay? So over here maybe cosine theta equals to 0, so theta equals to here 270 or 3 pi over 2, and alhamdulillah it is closed over here or included. And this one will give me cosine theta equals to negative half and cosine theta equals to negative half. In this interval there is one answer, that is 4 pi over 3. 4 pi over 3, let's see, 4 pi over 3, we said, okay, over here 4 pi over 3, and we wanted cosine equals to negative half. Here cosine is equal to negative half, so it's pretty good. So these are the two answers, the two only answers to this question. For this one you need Pythagorean identity that will help you change a tan to sec, and then you can have a party of sec, and so it will be easier for you to deal with them than having a tan and a sec. Okay, tan squared theta, remember tan squared theta plus 1 equals sec squared theta, Pythagorean identity. So I can just write this as sec squared theta minus 1 plus sec theta, and I'll put this inside with them, minus 1 equals to 0. So sec squared theta plus sec theta minus 2 equals to 0. So two brackets, sec theta, and I think one of them has to be positive 2, one of them has to be negative 1, to give me a positive in the middle and to give me negative 2. This says that sec theta is equal to 1 or sec theta is equal to negative 2. Okay, if I don't want to deal with sec, I can just change it to 1 over cosine theta equals to 1, or 1 over cosine theta equals to negative 2. Here swap, I will have 1 over 1 equals to cosine theta, or 1 over negative 2, equals to cosine theta. When in the interval it's from 90 to 180, yani quadrant 2 only. When is cosine theta equals to 1? Cosine theta is equal to 1 at 0 and at pi, and both of them are not included because here the pi is opened, so there's no answer for this one in this interval. While cosine theta is equal to negative half, theta is equal to pi over 3, which is in quadrant 2. You can check it on the unit circle. Question number 7. Over here I can say how can I do that? Okay, this is how I worked on this one. Cosine squared theta can be changed to 1 minus sine squared theta, Pythagorean identity. And if I take this inside as well, everybody is equal to 0. So I will have 1 minus, or okay, if I take both of them to the right side again, I'm sorry, so I'm going to have 1 equals to 2 sine squared theta. Okay, I'll tell you another easy way to do that. Or sine squared theta equals to half. So sine theta equals to, don't forget, plus or minus root of 2 over 2. And over here in this question, they said they want the answers in radians for all values of theta. So they didn't give me a specific interval, and they want the answer in radians. So over here they want root of 2 over 2 plus or minus, so all the quarters. This is pi over 4, صح? And 3 pi over 4 and 5 pi over 4 and 7 pi over 4. So why don't I just say pi over 4 or 45 plus 90? N, you need 90 times 1 would drag me here, 90 times 2 would drag me there, 90 times 3 would drag me here, and more of rounds and rounds. So I won't mention them all. I would just say theta is equal to pi over 4 plus pi over 2, and because there are answers every 90 degrees as you saw on the unit circle. How is it easier? I could have just said cosine squared